Alrighty, here we are. Got another stellar pre-calc lesson for you. We'll call this one, as you probably guessed, as it's the link that you clicked on. We'll call it 8-2 Day 2. So we're still in section 2, so the topic is still about operations with matrices. Today's objective is really specific. Can you multiply two matrices? Okay, so this is different from the first day where we did scalar multiplication. That's taking a matrix and multiplying it by a number. This is multiplying two matrices. Probably a brand new thing for you. There's a little more to it than the first day, which was scalar multiplication and adding matrices, which is why this one gets its own day. It's got a little bit more that we need to work on. So the first thing you might see here is you're like, hey, wait a minute. If you were thinking along the lines of the first day, that you can't do that, right? Over here, you have a matrix that is a 3 by 2, and you're multiplying that by a 2 by 2. The orders don't match, can't do it. Actually, no, with multiplication. That's what this first little line here is getting at, that the number of the columns of A have to match the rows of B. Now, if you write out the order underneath, here's the way I look at it, those numbers need to match. Okay? Those numbers need to match, and they do, which means it's possible to do it here. And even more than that, if you go with the outside two numbers, that is going to be the order of your product. So you're going to get a 3 by 2. And I will show you how this process works. So basically, I start in the top left right here, and on this one, think every time you're working your way across, and I'll start here, and we work our way down. So for example, I would do for the first, just keep it in mind here, this matrix is going to be a 2 by 2. I would do -1 times -3 plus 3 times -4. Okay, down to get to the next entry, I'm going to go down one row. Okay, think of it this way, that right now I'm building the first column of this matrix. Okay, I'm building the first column. So I'm working my way down. I'm going to do 4 times -3 plus -2 times -4. And now I go, and I'm going down to the bottom row now of the first one, but I'm still, this whole time with that second matrix, I'm sticking with the first column. So now I have 5 times -3 plus 0 times -4. Now, obviously, a little bit of number crunching to do there, but we would have our first column, when it's all said and done. Okay. Now it's time to build. I'm going to switch colors here to keep track of these. It's time to build column number 2. Okay. So now for that first matrix, I'm going back up to the first row, and I'm going to use -1 and -3. Okay, but now I'm switching over to the column that has a 2 and a 1. So it would look like -1 times 2 plus 3 times 1. Okay. Now I put these in different colors because I probably put these two columns a little too close together. That's not all one big expression. Okay, that first row, what's in red, I would number crunch that, and that gives me my entry that's in row 1, column 1. And then what I have in black, that would be row 1, column 2. Okay, so now on my first matrix, I bump down to row 2, and I have 4 times 2 plus negative 2 times 1. And finally, all the way down to the bottom, where I do 5 times 2 plus 0 times 1. And from this point, there's just a bunch of number crunching. Have 6 entries total. They should come out to be -9, -4, and -15. And then 1, 6, and 10. Excuse me, I gotta back up here. Probably another one of those cases where you were like shouting at me like, no, you're wrong, right? Our product that we were gonna get here wasn't a 2 by 2. I just hadn't finished drawing the 3 yet. That's what it was. No, that's not it. It's 3 by 2. 3 rows, 2 columns. Right, and again, that was coming from here and there. Okay? All right, let's hop down here and do another one. Okay? First of all, just to double check here that we can do this, because in this lesson and in your homework, you're going to come across somewhere you can't. This is a 2 by 3. This is a 3 by 2. Okay, those match, those inside numbers, the columns of the first one and the row of the second. So we can do this. The product is going to be a 2 by 2. Now I'm going to leave a little space here because this, for writing out the steps, it can get a little bit lengthy. Not too bad. Okay, so to start with, I go with the top row and then the first column. And you work your way, again, think we work our way across, and here we work our way down. So for example, I go across the top row here and I have 1 times -2 plus 0 times 1 plus 3 times -1. I would have to number crunch that, and I would have the first entry. That single number would be row 1, column 1. Okay? So now go down to row 2 in the first one, but again, stick with column 1. Okay? -2, 1, and 1. So now I go 2, -2, -1, 1, -2, -1. Okay? And at that point, column number 1 is complete. We'd have, a little number crunching to do, but that would be our first column. Now we're moving over to column number 2, which means this is the column that I'm going to use. So I go back up to the first row of matrix A, which is 1, 0, 3. I'm going to use that one again, and we're going to go 1 times 4 plus 0 times 0 plus 3 times 1. And then we'll bump down and go 2 times 4 plus -1 times 0 plus negative 2 times 1. Should end up with a 2 by 2, so we'd have basically 4 little components of number crunching to do. Should come out to be negative 5, negative 3, 7, and 6. And there is our product. All right, this one looks a little nasty here. We have ourselves a 3 by 2. That doesn't look so bad. We've worked with that case. But how about a 3 by 4? And I would expect that you could go up to do it like a fourth dimension, a row or column, but that's really not the point of this one. Okay, to this I would accept 2 answers. If you identify that those numbers don't match, you could say no solutions. I would take that. Or just one of these two. You wouldn't have to say both. You could also just say that it's undefined. All right? But I do want to see you write out the dimensions to verify that you see that it's because the columns of the first don't match the rows of the second that one is no solutions. All right, a couple interesting little cases here. They're kind of oddball cases, a little bit, because they only have either like one row or one column. But what I want you to see here, even more than that, this is the same 2 matrices. I'm just going to multiply them twice, but I'm going to switch the order. Okay. And what I want you to be thinking about is, hey, do we have the same kind of scenario with matrices as with numbers, that when we multiply, the order doesn't matter? Right? In other words, 4 times 2 is 2 times 4. In either case, that equals 8. Okay? So think about that as we work through this. Matrix A is a 1 by 3. Matrix B is a 3 by 1. Okay. Hey, take a look. Yep, they match. But our product will end up being a 1 by 1 matrix. We go 1 times 2. And again, I'm working my way across the first one. So I move over to negative 2. And I'm going down the second one. And there we go. Should only have one entry. Basically, as you simplify this, you have 2 plus 2 minus 3. So it is a 1 by 1 matrix with just the entry of 1. That's what you get. All right. So let's move down to part B and let's swap the order. And okay, we should even just double check here to say, can we do this? We now have a 3 by 1 and a 1 by 3. Now this will be pretty interesting. The inside numbers match, so we can do it. These are 2 matrices that can be multiplied, but it's pretty clear it's not going to be the same matrix, because here we're going to get a 3 by 3. We're going to get a 3 by 3. And so in general, what you can take from this is if you switch the order of two matrices that you're multiplying, it matters quite a bit. It's not like multiplying numbers where you get the same thing. You'll even have cases where in one order you can multiply them, and if you switch the order, it's possible that you can't, that you would, you wouldn't get any solutions. So here's what it would look like. I'm getting a 3 by 3. So I start with 2 and 1, so I multiply those, and I'm supposed to go across the first one, but there's nowhere to go. And I'm supposed to go down the second one, but there's nowhere to go. So that's it. That's row 1, column 1. So now I'm going to move down, and I'll go -1 times 1, and then finally 1 times 1. Okay. Now you can think about it as, I'm going to go back up to the top for this middle column, but I'm not going to multiply all of those by 1. All of these are going to get multiplied by -2. And then we'll go back up again, and you can probably guess what number all these are going to get multiplied by. If you said -3, I got news for you. You are totally correct. So that's fun. Oh, a bunch of number crunching to do. 2, -1, and 1. How about -4, 2, and -2? -6, 3, and -3. Yeah, so we switched the order. This was a case where we could still multiply them, but if you'll notice, not at all the same as the first product where it was just a 1 by 1.